Hi, welcome to the third episode of the Machine Tool Flow Creator tutorial series. Last episode you learned how to work with low frequency data on the SINUMERIK, and this episode will be about how to work with high frequency data. We will program an application where we read high frequency data from the data bus, and then we calculate a moving average over it, and in the end we plot it on a dashboard. But before that, let's talk about the term high frequency data.
High frequency data is the term for deterministic and synchronous communication, and the acquisition rate equals the position controller clock, so it can reach up to 1 kilohertz. And the data access is really efficient because you can read up to 100 different variables simultaneously without stressing the NCU. That makes 1 million samples per second. When we talk about SINUMERIK high frequency data, we usually mean set points and current values of the position controller, speed controller or interpolator, or currents and torques of the different axes and spindles. And you can also read synchronous action variables or NCU linked variables, and you have the chance to access the Profinet and Profibus ranges. Let's take a look how the edge receives the SINUMERIK high frequency data. We start on the NCU side. There we have the position controller, which delivers data in a constant cycle. Then we have a piece of software called HF Probe, which collects the data and writes the data into the edge file system. There, the data points of multiple cycles get stored before they are transmitted to the edge box. And on the edge, we have the SINUMERIK adapter, which receives the data and merges all of the data points into one package and sends this package to the edge internal data bus, and other apps can subscribe to that data. The data is available in a JSON format, and you have all of the data points in one message, and also each message contains multiple values of each signal because multiple cycles are collected before they are transmitted to the edge. The specification of the data format can be found in the online documentation.
The first step is to select what variables we want to subscribe. Therefore, we go to the app management of the MindSphere, open the asset, and go to the Machine Tool Flow Creator. We open the app configuration, and there we can configure all of the data points that we want to subscribe. Therefore, we need to go to the data source config, to the services, and to the subscription service. And in the subscription service, we already see that we have the SINUMERIK high frequency data points selected. There is a little set of variables that is already subscribed. If we want to add a new one, we just need to add an object, type in address, and then the address of the variable we want to subscribe to. Further information on the different high frequency variables can be found in the documentation. But first of all, that's enough, and we save the configuration, and we can check the progress of the configuration job in the jobs section. After a short time, the job is finished and we can go on.
Let's switch to the flow creator. We start with a blank flow, and I call the flow tutorial 3 SINUMERIK HF data. The goal of the first flow is that we get high frequency data from the data bus. Therefore, we insert an inject node again. This inject node is used to initially trigger the flow, and to do that we need to select the checkbox at the bottom of the inject node, and now the inject node will start once in the beginning. And the second node is the data bus consumer to read the high frequency data from the data bus.
We connect both of the flows, and now we insert a JSON node to convert the string output of the data bus consumer to an object. And in addition to that, we insert two debug nodes. One of the debug nodes is used to display the output message, and the other one is used to display the data bus return code. So now let's change the name so that we know which debug node shows which message. And after we did that, we can check if the programming was correct by deploying the flow. And after that, we should instantly receive the high frequency data.
Let's take a look into one of the packages. Therefore, we deselect the debug nodes, and then we can open the message payload property, and there we see the array which contains the 46 subscribed HF data points. The next step is that we use some link elements to connect multiple lines of the flow. So first a link out element, and then a link in element, and then we can drag and drop the virtual connection. The next step is to use a change node, which will be used for the configuration of the flow. The first thing we want to configure is which data point should be used for the moving average calculation, and the second property is how many values should be used for the moving average calculation. The first rule is that we set the subscribed data point to an exemplary value. In my example, I use the variable current1, so the current signal of the first axis, and the second property is the number of data points, and I call it n moving average, and by default I set it to 25. Now we can close the change node, and the next step is to insert a JavaScript function node, and this is a JavaScript function which will be executed whenever a message is passed to the input, and in our case we use it to calculate the moving average. And in the first step we want to calculate the average over each package, and in the next step we calculate the moving average over multiple of these average values. So first of all, I delete everything to declare the variables that are needed for the programming. The first variable is the HF data points array, and for that we need to read the array that contains the data points from the message, and you can find it in message payload body and then data point. And on the right side we see that the data point array contains all of the 46 subscribed data points, and then the next step is to declare the variables that are needed for the average calculation, so the sum and the average, and then we declare the variables that are needed for the moving average calculation. And finally, we declare two variables that are stored in the context tab. So the first one is averages, which is an array that contains the last averages. And we can read it by entering the function flow.get and then the name of the variable. And we do the same for the last moving average value.
The next two variable declarations are the variables which we configured in the change node. So the first one is the subscribe data point, which we can read from the message property subscribe data point, and the second is how many values will be used for the moving average calculation, and this one is called n moving average, and we can read it the same way. Both of the variables are constant, so they're not changing, so we can use the const tag to declare it. The next step is to initialize the global variables which we are using in the function node. Therefore, we can use the change node again. And in the change node, we select the variable flow, and then we can declare the averages, and this is an array, so we declare an empty array. And now we add a second property we want to declare, and this is the variable flow dot last moving average, and we declared with the value 0. Now we clear the message object and create a second message object. The background is that the first message will contain the value of the signal, and the second message contains the current moving average value. Then we give a name to these two messages. The first message has the name of the subscribed data point, so we type in message name equals subscribed data point. The second message name will be the subscribed data point and the information that it's the simple moving average. And we also add the information of how many values we use for the calculation of the simple moving average, and this value is stored in the variable and moving average. So we concatenate the different variables by using the plus signs, and then we have a string which contains all of the information.
Now we can start with the calculation of the actual moving average. For that, the first thing we want to do is to find the data point in the package which we want to calculate the moving average for. And then the next step is to build an average over all of the values of this package, because each package contains roughly 100 values of this data point. So for that, we do a for loop in order to loop through the HF data points, and then we check with an if statement whether the address of the current HF data point equals the name of the subscribed data point. In that case, we want to get the HF values and calculate an average over them. To get the HF values, we check the structure of the package. So we want to have the content and then the value array. So we type in HF data point dot content and take the first element, and this is the value array, and there we have the HF values. The next step for the average calculation is to determine the length of this value. We can do that by simply using the length property. After that, we build the average with a for loop, because first we need to determine the sum over all of the values, and we do that by simply adding up all the HF values of this data point. After that, we can determine the average value over the package, and this is the sum divided by the number of data points. After we did that, we pushed the average value to the averages array, because we need that for a later calculation of the simple moving average. We take online calculation algorithm for the simple moving average, because it only requires the value of the last moving average. And the first thing we do is to check if we already have enough values to calculate the moving average. For that, we check the length of the averages array, and if that's the case, we can do the online calculation algorithm. Therefore, we take the current average divided by the number of elements we want to include in the moving average, and then we take the first element of the array and also divide it by the number of elements we use for the moving average. After we did that, we can shift the averages array. That means that we push the first element out of the array, because we only want to have a window of values for the moving average calculation. We need a certain amount of values to calculate a moving average. So in this statement we check if we already have enough values in the averages array, and in that case we can calculate the first moving average. And we do that by determining the sum over the averages array and then divide it by the number of elements that are used for the moving average. So we already did that before. We take another for loop and loop through all of the elements of the averages array and build a sum over it, and then afterwards divide the sum by the number of elements. The last step is to calculate the current moving average, and for that we use the last moving average value and add the moving average delta to that value. For the calculation of the next moving average, we need the current moving average and the averages array. So for that we set the flow context variables to the current values. After setting the context variables, we create two message objects, which will be passed from the outputs of the function node to the next node, and the payload of the first message is the current average value and the message name is the topic. And for the second message we have the current moving average as a payload, and we use the message name 2 as a topic. The last step is to return the message objects, so to pass the messages from the function node to the next node, and for that we check if we already have a moving average calculated, and we can do that by checking the length of the averages array, because this needs to be longer than the number of elements we used for the moving average calculation. In that case we return both of the message objects. If that's not the case, we only return the current value of the signal and pass null as the moving average value. That's all the programming we have to do, so we can close the function node and click on done. The next thing we want to do is to insert a chart to display the values of the signal and the moving average, and for that we use the chart node from the dashboard library. Insert it next to the function node, connect both of the nodes, and the first thing we want to do is to change the label of the node to moving average. And the next thing is that we need to add a new tab to the dashboard. The tab is the main page, and on the tab you can organize multiple groups. So we go to the dashboard section and add a new tab. This tab is called Machine Tool Flow Creator Tutorials, and on that tab we add a group which is called Tutorial 3. SINUMERIK high frequency data. and we can add the node to that group. After that, we create an inject node, which has the task to clear the chart every time we restart the flow, because otherwise the time series data will be saved. For that, we place the inject node connected to the chart, and then we have to inject empty arrays into the payload and topic properties of the message. Now there are only a few changes left. The first one is that we need to enable the legend of the chart. Therefore, we open the chart node and select show to show the legend. Next up, we need to adjust the width of our chart element. Therefore, we go to the dashboard tab, select the group where we have the chart element in, and adjust the width to 20. And the last change is that we need to add a second output at the function node so that the two messages can be passed to the chart node. And we connect the output of the function node to the chart node and deploy our final changes. And now we can switch to the Node-RED dashboard in order to display our data. Okay, let's switch to the dashboard, and as you can see, there's already data coming. In my example, it's current data from the first machine access, and you can enable and disable time series by clicking on the legend. And as you can see, there's a simple moving average for the last 25 values, and it's also reacting to changes in the signal. And if you want to change the number of values, you can see an example here. I changed it to 10 values, and the simple moving average is more sensitive now for changes in the signal. In this tutorial you learned how to subscribe to SINUMERIK high-frequency data points, how to read them from the data bus, work with them using function nodes, and finally how to plot them using the Node-RED dashboard library. In the next tutorial you will learn everything about OPC UA and how to work with it on the edge, so make sure to click on the next tutorial and see you there.